So today we're going to learn about parabolas, and before we get started, we need to talk about some definitions, okay? So a parabola is the set of all points in a plane that are the same distance from the directrix, which is a fixed line, and a fixed point not on the line called the focus. The main thing that I want you guys to get is that the directrix is a line and the focus is a point, okay? And the p-value is the distance between the vertex and the focus and the vertex and the directrix. And we're going to look at a picture so that we understand what all this means, okay? I'm going to point it out for you. Just write that down so far. Okay, let's look at a picture of what this looks like. So guys, this is a picture of a parabola. A parabola is a curved line. It's a U shape. So this is a picture of a parabola. This is our parabola. Let's go ahead and label the vertex. The vertex is right here. So everyone label the vertex. Draw an arrow to it. This is my vertex. That's my vertex. Now, the focus right here. This is my focus. It's a point. The focus is always inside of the parabola, okay? So actually, guys, right here in the box where it says focus, let's write the definition one more time. Focus is a point inside the parabola. It's important that you remember that is inside parabola. Okay, and let's go ahead and label the rest of this picture. This line right here, this is called the directrix. And the directrix is a line outside of the parabola. So let's write that in our notes right here. It's a line outside the parabola. That's what we need to remember today. Let me highlight some things that are important. So here's your focus, here's the vertex, and here's the directrix. The space right here, let me erase some things. The space right here, let me highlight it. This space is called the p-value. This space is the p-value. So the distances are going to be the same, okay? All right, so this equation right here, it'll open up. This one will open down. Do you guys know why? Yep, there's a negative in front. That's why this one, if your equation looks like this, it'll be facing down because there's a negative in front. Your vertex is going to be the same for both. Your vertex is always this number and this number. It's always the h value and the k value. That is what makes up your vertex. So your vertex is always h, k. And the axis of symmetry is x equals h. It is also always this number here, which gives you the axis of symmetry. Okay, so now that we have these notes, let's go ahead and look at an example. Before we move on to the example, I just want to point out an important part of the equation. I want you guys to turn your attention to the equation. Right here, where it says 4p, that is always the format. In the denominator, it'll always be 4 times a number, okay? It'll always be 4 times a number. And we represent that number with the letter p. Okay, let's just keep that in mind for now. So let's look here. This is our equation. Now, before we get carried away, let's figure out what the vertex is. It's always this number and this number. So what should my vertex be? 1, 4, not -1. So let's look at the equation right here. It always has a minus there. That's not a part of it. I just want the h value and the k value. So we're not going to take that negative. So my vertex is 1, 4. So let's go ahead and plot the vertex. 1, 4, my vertex is right here. Will it be facing up or down? Down, because there's a negative right here. So I know it's going to be facing down. So you guys can write the word down. So when I graph it, it's going to look something like this. It's going to be facing down. And what is my axis of symmetry? Yep. So my axis of symmetry is going to be x equals 1. Because if I split down the middle, it crosses the x-axis at 1. Okay, now let's figure out the rest of the part. That's where our equation comes in. So let me highlight the important part that I want you to focus on. Notice this right here. This 12, remember normally the format is 4 times p. That's the equation. The format is y equals 1 over 4p. So guys, if there's a 12 right here, what was my p value? 3, because 4 times 3 would give me that 12. So that means my p value is 3. Everyone put 3 for the p value. So I can rewrite this denominator as 4 times 3, which will give me 12. So my p value is 3. Okay, so guys, that is the distance of the focus and the directrix. Your p value tells you where to draw it. So I'm going to go 3 spaces. This is my vertex. Go 3 spaces inside of the parabola. That's my focus. So I'm going to draw an arrow to it. That is the focus. The focus is a point inside of the parabola. That's at 1, 1. So my focus is at 1, 1. Now I'm going to go 3 spaces outside of the parabola. This is right here. So that's where my line will be. That's my directrix. So your p value tells you where to draw it. That's the directrix. Okay, I can't write the x. Okay, so this crosses the y-axis at 7. So my directrix is y equals 7. And we're going to do another example. We're going to do several examples until you get the hang of it. Okay, example number 2. This time they gave me the vertex and the focus. So let's go ahead and plot that. The vertex is at -3, 0. So I'm going to go to -3, 0 and put a point. This is my vertex. The focus is at -3, 2. -3, 2. This is my focus. So I'm just going to draw an arrow to that. That is my focus. Okay. Now, I want everyone to write the definition one more time. The focus is a point inside of the parabola. It's a point inside the parabola. So guys, how should I draw my parabola so that the point is inside? Does it need to face up or down? It needs to face up, because the definition of a focus is that it is inside of the parabola. If you drew it down, it would be outside. We can't have it outside. The definition of focus is that it's inside of the parabola. So I know that it needs to face up. Okay. How far is the vertex from the focus? How many spaces away is it? Yep, it's 2 spaces. So that means my p value is 2. Now, if my focus is 2 spaces away, that means my directrix also needs to be 2 spaces away. So this is my directrix. They need to be the same distance away from the vertex. Label your axes. This is the x-axis and this is the y-axis. Now, this is my directrix. Go ahead and label it so we don't forget. As we're learning these things, I want you to label it while we're learning it. This is my directrix. It's a line. The directrix crosses the y-axis where? At -2. It's right here at -2. Okay, so all we're missing now is the axis of symmetry. Okay, if I split this graph down the middle, it crossed the x-axis where? Yep, -3. So x is -3. It's always the same as this number. Okay, now let's do the equation. I'm going to copy the equation from our notes. So I'm going to go back to our notes. I'm going to copy this equation right here. Let me highlight it for you. This is the equation that I'm going to copy. Okay, so let's go back to our example problem. So it'll be y equals 1/4p x minus h squared plus k. Okay, so guys, what did we say our p value was? 2. So I'm going to erase this p and I'm going to put a 2 there. Okay, now h and k represents my vertex. So guys, my vertex, they gave it to us. This is the h value, this is the k value. So I'm going to erase h and k and replace it with the vertex points. So the h value is -3 and the k value is 0. So that is my equation. Now, of course, I'm going to want to simplify that and make it a little prettier. So I'm going to go ahead and simplify it. 4 times 2 is 8. Whenever I have 2 negatives next to each other, they can just become a positive. And I don't really have to write +0 on the end. So this is my answer. That's my equation. All right. Now we're going to try the next example. Okay, next example. This is what they gave us. They gave us the focus, which is 4, -3. So go ahead and go to 4 and -3, plot a point. This is the focus. Please label it. And then they said the directrix is the line y equals 5. I'm going to go ahead and label my x and y axis. This is the x-axis. This is the y-axis. So y at 5 is right here. So I'm going to draw a line that goes through 5 on the y-axis. And this is my directrix. Now, guys, where do you think my vertex should go? Shouldn't it go in the very middle? The vertex needs to be the same distance from the focus as it is from the directrix. So it should be in the perfect middle point. So let me see how many spaces this is. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. So the very middle would be right here. So this is my vertex. Draw an arrow to this. This is my vertex. Should my graph face up or down? Yep, it needs to face down. Because the definition of a focus is it's a point inside of the parabola. My focus needs to be inside of the parabola. And the directrix needs to be outside of the parabola. So that's how we should draw it. So let's write all this information down. I know it's opening down. The vertex that I just drew, that's at 4, 1. This is my vertex right here. That's at 4, 1. Axis of symmetry, where is that at? 4. So you're going to put x equals 4 for the axis of symmetry. Okay, now let's talk about the p-value. What is the distance from my vertex to my focus? How many spaces away are they? 4. 1, 2, 3, 4. They're 4 spaces away, as well as 4 spaces away this way. So my p-value is 4. Now I have everything I need to write my equation, okay? So we're going to go back to our notes, and I'm going to copy down the equation. It's y equals negative, because it's facing down, 1 over 4p x minus h squared plus k. Now I'm just going to fill in everything that I know. What is my p-value? 4. So I'm going to put a 4 right there where my p-value goes. And I'm going to erase h and k and put my vertex in there. So it'll be 4 and 1. So guys, notice my equation, it says x minus 4, even though my vertex is 4. It's always opposite. Remember, it goes to the right 4, which is what it did. It went right 4, up 1. And that's my equation. We can also simplify this. So I'm going to write it as y equals negative 1 over 4 times 4 is 16. So you can simplify this. Okay, so your final equation should look like that. We simplified 4 times 4 to give us the 16. All right, I'm going to do one more with you guys, and then you can move on to the practice. Are you guys ready? Okay, last problem. Okay, this time they gave us a picture. So my vertex is right here. What point is that, guys? Yep, 0, -2. So my vertex is 0, -2. What else do we know? Yep, the axis of symmetry. So the very center is at 0. The x value is 0. So I can put x equals 0. What else do we know? Yep, the p-value is 1. And the way we figure that out is the distance between the directrix and the vertex is 1 space. They're 1 space away. So my p-value is 1. Which direction is it opening? Up. So I'll go ahead and write the word up. And they gave us the directrix. This is the directrix right here. I'm going to go ahead and label it. This is the directrix. It's a line outside of the parabola. And it crosses the y-axis where? -3. So guys, don't just write -3. It's y equals -3. It's a line. Equations, you need lines. You need equations for lines. Okay, we need 2 more things. My focus, yep, it's going to be 1 space away as well. We're going to go up 1 space. So that's at 0, -1. All right, let's go ahead and write our equations. So I'm going to have y equals 1 over 4p x minus h squared plus k. And we'll fill in all the information. So my p-value is 1. So I'm going to put a 1 in there. And then h and k, my vertex. So the h value is 0, and the k value is -2. So I'm going to put 0, -2. This is h, this is k. All right, so now let's simplify this. I can write this as y equals 1 over 4 times 1 is just 1. So I'm going to write 4 times 1, that can just be written as 4. And x minus 0 is just x. So this is just x squared minus 2. If you want to, you can put parentheses, but you don't really need parentheses. There's nothing else in there besides x. All right, so I'm going to end here. You guys can go ahead and do the practice. All right, guys, so before we end this lesson, let's talk about domain and range real quick. So the domain is always going to be the same. It goes forever to the left and forever to the right. So my domain is just going to be all real numbers. Negative infinity to infinity, or you can write it like this. Capital R, a double barred R. And now let's talk about the range. The range is only talking about the parabola. So let me highlight what we're going to look at. We're just looking at the parabola. We're not looking at the directrix, just the parabola. So the very bottom of the parabola is right here. The bottom is at negative 2. So my range, the range is negative 2, and it goes up to infinity. So that's the range for this one. You could also write the range as all the y values are greater than or equal to negative 2. This whole parabola is above negative 2. Everything's above negative 2. So that's how you can write the range. Let's look at the one before it. Example 3, it's facing down. So let me clean this up a little bit. All right. Okay, so let's talk about the domain and the range for example 3. Well, the domain, it goes forever left and forever right. So my domain for this example is the same, all real numbers. Let's talk about the range this time. So the very bottom, it has arrows. It goes down forever. So what is that pointing to? Negative infinity. So for range, you always start at the bottom and then you go up to the top. So the top is up here at 1. So the range is negative infinity up to 1. You can also write it as all of the y values are less than or equal to 1. This whole parabola is below 1. So everything is less than 1. So I put y is less than or equal to 1. That's the domain and the range. If we go back to example 2, the range, the very bottom, this is my parabola. Let me highlight it. This is my parabola. The very bottom is right here at 0. So that means my range is 0 to infinity. The bottom is at 0 and it goes up. You can also write it as everything is greater than or equal to 0. Those are the two ways you can write the range. And of course, the domain is just all real numbers. You can write it like this, or you can put negative infinity to infinity. Okay, so those are some examples on how to do the domain and the range.